Hi, welcome to the New York City F-sharp user group. Today we have Riccardo Terrell, an old friend, and he runs the F-sharp user group in DC. So I'll just hand it off to him right away.
All right, thank you, Rick. And thank you all for coming. Very excited to be in New York tonight. I mean, I promised Rick to come here like over a year. I apologize tonight, and I feel still that to wait up with him. So anyways, thank you for coming. Tonight, a great topic. I'm excited. First reason, because there are some technologies here that really care about it. And second, because this is the first time I do this presentation, so we're going to make it. But, so actor clustering with Docker containers in nyc-fsharp is a long title. However, it'll be misleading because there's even something else we're going to cover here. And we'll see later. So this is the agenda we're going to cover. Talk a little bit of actor model. Just a little bit. I did a talk about actor model a while ago. This is like a phase 2, right? Some more advanced topic. It's like the second part of this presentation. So I'm going to just touch base about actor model just to give an introduction. Then we're going to cover some more advanced topic, remote in clustering, code-quotation, and you're going to be clear why. Then something called Tabasco, something that I'm working on it, and something super cool that is about remote deploy arbitrary actor. But think about that we can even remote deploy assembly dependencies, that kind of stuff. So it's gonna be super cool. I'm excited.
Is it Tabasco because it's hot?
Yeah, it's like hot. Actually, Tabasco, there is a Piri, like the African place, very hot.
Okay.
In Tabasco. So actually the library has some name Tabasco, some name Piri, to make it consistent.
Nice.
Yeah. So I'm gonna cover a Docker container. The goal here, we're gonna, really important, the fact that you can leverage F-sharp code quotation with Akka.NET to overcome some limitation. We're gonna cover very well how remote deploy actor behavior and so on. It's still hot. But really what I'm passionate about is the fact that just combine different technology that merge together to solve a problem. This, I think, is very fascinating. The bonus slide about me. That's my beautiful family, with my wife and 2 love dogs. But I'm originally from Italy, where my accent comes from. I've been around working 19 years, so it's a bit a while. But I'm the organizer of this F-sharp user group. And Rick already came over, but you're all welcome to come and stop by. And working for StatMuse, recently a sweet job, like 4 months ago. We do natural language processing for stat in sports stats. And I do believe in polyglot programmer. Who doesn't, right? Okay, but it's not about me, it's about you. So, as I mentioned, there's a lot of topic here to cover. So I want to adjust the talk as we go, but how many of you are familiar with distributed system? Okay. And how about using the actor model? Maybe just know in the .NET ecosystem, okay? How about just .NET ecosystem, like Akka or, okay. So it should be interesting for you that to work in distributed system, actor model, to be able to remote deploy in just a system that doesn't know anything about any actor. Arbitrary behavior, arbitrary actor also include dependency? No one? Okay, this is the wrong talk. So let's face the scenario here. That's actually what we're gonna do later in the code, and we're gonna talk about it. Let's start with a simple actor, right? And I'm gonna talk about the actor coming soon. But an actor communicates with another actor, right? But our actor had to have some sort of configuration. In this case, has some remote configuration, so they communicate with an actor how the process for different machines. And of course, they had to have some sort of implementation. So I know it's too small, but don't worry about the code. We're going to see plenty of code later. So I had to know some sort of implementation of some actor. So to communicate with the other actor, also the other actor has some sort of configuration that know how to talk with each other, but also some sort of implementation, right? So that he knows how to handle the message when they receive the message process. So then they can, share messages and be happy. And this is, of course, happening in 2 different machines, okay? But things start to be more complex if one actor, let's say the master, have some dependency or some assembly, right? When I send a message to the remote system, well, to handle the message, this actor probably to know about this assembly, probably to deploy the same assembly, and so it starts to be a bit complex. Think about it, you spawn multiple actors, right? Every actor to have this kind of information. So I think it should be nice if you start to remove this sort of dependency, okay? And what about even further down, we remove this dependency. So at this point, our remote system is completely agnostic, right? We can just send a message, and through, I call it dynamic loading, we can remote deploy a behavior and also include some dependency. So now our actor is able to handle the message as the sender is intention to. All right, by the way, if you have any questions, just shoot me, yell me right away. I better answer the question when I'm context. All right, so let's start a little bit talking about the actor model. Yes?
Did that arrow down at the bottom mean that it was getting the things that it needed to fulfill the dependency from the originator?
Hold on, we're gonna go over that part. Yeah.
Okay.
Sort of yes. So what and why? So, well, first of all, we are in a multi-core era, right? It's all about parallelism these days, but we are dealing with languages that weren't designed with multi-core in mind and also programs, right? So right now, the majority of programs out there still leverage one core, and then if you write a program probably using mainstream languages, there is some complication coming with that. So, a classic approach, you can spend multi-thread, pretty easy in theory, but in practice, it's a bit different, right? It's more complex. So what's the problem? Anybody?
Dogs aren't that good.
Shadow state, huh?
Dogs aren't that good.
Yeah. The shadow state, right? Because in traditional mainstream languages, we have this mutational state that complicate the parallelism, right? Think about if two threads like this line here access the same space in memory, and one thread change the state and leave it corrupted for the following thread that access, well, your program start to behave in a wanted behavior, right? So the solution, of course, traditionally we have logs, semaphore, and so forth, which of course add complexity, right? First of all, it reduced parallelism because just the name logs, it prevents running parallel, just protect the space in memory. But besides, there are not many tools, or even the debugger can tell you if you put the lock in the right place, right? So you can run in programs such as race condition and deadlock and so forth. So let's bring up one great solution that I really like is the actor model, right? It's a pretty old concept because was written, the idea started in '73, but the original idea came from even early from mathematical theory for communication. And just these days, it kind of more trendy, like, a lot of companies using AutoComp model in the back end, like Twitter and WhatsApp and so forth. Well, because it's becoming a reality to deal with this multi-core era, and it turned out that the actor model really deal quite well, fit quite well. So what is an actor, right? It's an independent unit of computation, which has a single thread that processes an internal mailbox and apply the behavior to one message at a time. And the actor contains a state. However, the state is isolated. Only the actor can access that, right? Which means that there is no issue to have race condition, right? Because it's single threaded. But in the message that they receive to the actor are asynchronous, no blocking, right? From the outside world, it's fast, right? You can, I think you reach like 40 million messages per second, something like that. So it's crazy fast. And what brings also the benefit of the actor model are other features, such as remote clustering and supervision. For instance, think about the actor model as a rental car, right? You drive the car, and if you broke it, you don't care to fix the car. You just live in a ditch, right? You call rental company, and they send you a new actor. So all these features are built in all the actor model framework that you can find there, or you can build your own. But really, truly, isolation and immutability are the two secret ingredients for the grammar SAS, right? This is and the actor model really provide both out of the box. Messages are passed by value, so they're immutable, and the state is isolated, right? So actor model definitely is a great alternative to traditional concurrent programming model. They solve a lot of problems. And let's bring it to the Akka.NET, which is, if you're probably familiar with the JVM, right? Everybody familiar with the Akka from the JVM? Yep. So this is the port from the JVM to the .NET platform. It really is a toolkit for building concurrent, resilient, distributed, and scalable system, which is a lot of buzzword, right? But really, what the intention here really simplify the implementation of synchronicity and task-based operation with a very simple programming model, with a very simple API. And we're going to cover the advanced side of Akka, which means remote and clustering. We will see probably actually we see some slides about how the actor is implemented. But if you have any question about message passing or this sort of stuff, let's go. So briefly, the actor really use underneath the scheduler, right? So they're very cheap. So you can fit almost 3 million actors in a gig of memory, right? Compared to the traditional threads, right? Which is one meg each in a 32-bit machine. And actors are very cheap, which means you literally compose your model using actors, right? And I heard a lot of time people ask me, hey, but what should I do in this case, right? I mean, is some sort of edge case? Should I create some other different logic in these actors? And why create some extra behavior in the same actor? Just create a new actor, right? They're cheap. So really build up a sub model using actors. As I mentioned, the great part about the actor is able to self-heal. You're able to something happen to catch an exception for you and bring back the system in shape it was in the beginning, and that's using a supervision, right? Parental supervision, which means that the actor that creates another actor become responsible for the child. So if the child throws an exception, the parent catch it and apply some behavior to the exception, which you're in control of. You can inject any sort of logic that you want for the specific error. And yeah, as I mentioned, just apply your own behavior here for the exception. There are two main strategies, one for all and all for all, but when you bubble up the exception, you can pattern match it against the type of the exception, or even for the noun, the message and so forth, really to narrow down what specific logic you want to apply. But just let it crash. There is no reason to use try-catch block using the actor model. If something goes wrong, just let it go, right? The system is able to self-heal. You can, the actor go down, instead of go down the system or the process, you can decide to make a new actor, right? And you can even preserve the state and inject the new actor, which probably is not the right approach, because sometimes the same state is the one that creates the exception in the first place, but there are different approaches you can use. So how this actor looks like, right? So this is actually C#, but this is a type actor, received actor. And there are two main type of actors, the type and untype, which is pretty self-explanatory, right? But this is a type actor, so we know exactly what kind of message is coming in, which is the fizzbuzz message. And when the actor receives the message, you put the logic to handle it. You should create a system actor, which is the system where all the actors belong to, okay? This is like the top, the root of your actor system. And then you create the instance, your actor passes some props, some configuration, right? In this case, it's simple, but we're gonna see in a code sample. Yes?
So a system is for one computer? Or is that?
Well, you can have for one process.
One process.
Yeah.
Okay.
You can have also more system for the same process, but I would avoid that. So the props, you can pass different properties, right? Like supervision strategy, you can pass sort of a routing algorithm for how dispatch the messages and so forth. And then just send a message with the tell. And of course, this we see later can be remote too. Another kind of actor implementation, this is still type, you just use the iHandle interface, which is probably use case when you use like dependency checks on your application and so forth. But otherwise, other than that, the same exactly configuration strategy here. F# implementation, we have two options. One, follow exactly the same C# semantic approach, with the inheriting your actor. This case actually is an untyped actor, which receive a message object, and you pattern match against the type to figure out. Now, why you want to have untyped actor? We like type checking, right? Any Python program? Anybody? Why do you think we need untyped actors? Anybody?
The C# doesn't have union types, so you want to be able to pass lots of different things.
Actually, we can do pass union type. We're gonna see it. We use a pickler for that. But the reason is because, especially in implementation of Tabasco, or in other cases when you remote deploy, you can use untyped actor, especially in F#, not C#, because we will be able to out-swap a runtime the behavior and actor, right? Now, if you think about it, you cannot change the signature though, right? So you can remote deploy an actor with the behavior and just change the behavior and handle different kinds of talkback messages. And of course, we have the functional stuff, right? Because overall, an actor, the behavior actor is a function, right? And we like function. So this is the functional approach for F#. Use the spawn function. There are other. Take a system as argument, the name of the actor, and a function that use a computation expression here, the actor one, that just recursively and asynchronously wait for the next incoming message. And here, the weird symbol is a fixed operator to just send a message. I put the signature in Greek terms. All right. Now is a teaser. I think I'm going to cover remoting first. Sorry. But remoting just feels like, and then we're going to jump to the first one. I think it's better fit. So what is remoting, right? Well, remoting is a module in Arca.net used to communicate between system peer-to-peer fashion, right? And really, this is remoting is the foundation of the clustering we're going to cover later. So remoting, as I mentioned, communicate between two systems, right? And the system is responsible then to dispatch the message to the right actor or actors. We have a configuration from the server side. In this case, it is the receiver, which had to expose a port. And of course, if you remember in the previous slide, he had some pre-knowledge, pre-configured, pre-packaged, pre-deployed actor, right? Because when you receive the message, it doesn't know what to do. Well, if you send a message and it doesn't know what to do, the system just send the message to the dead letter actor, so nothing happens. But you can override that and handle it differently. And of course, the client that sent the message, well, you have the configuration as before. You create an actor, in this case the props, and able to send a message to the actor. Now the two remote actor, because they know that there is the same actor, the same message type, they know that's actually what they belong to. However, you can, in this case, the remote echo is the name of the actor. You can use in a path to target a specific actor. To me, this is great, but there is a limitation here, right? If you go back to this line, to the fact that we have to already a pre-configured, pre-deployed actor already there. So everything is designed in Akka to work in a distributed system, right? And remoting really provides this unbounded scalability, right? Because now you can send a message to a local or remote actor, but then you add the system in the back that spawn more actors depending upon the payload that you have to handle, right? To distribute the work. But what I like, and I think you can see between the two hearts, you have the same API, right? You can send a message locally or remotely, uses exactly the same API, and this is possible to location transparency. And think about location transparency that it really doesn't matter. You don't need to know where the actor is locally or remotely, right? Or in a different machine process. Just the actor system take care of that everything for you. In this case, we have a path, which is the remote actor system, the address, which is, in this case, localhost, but should be the PO, the remote machine. And of course, the path of the actor. If you don't specify the path, but you send with the probe the type of message, you're going to make the mapping for you. So think about really as a phone call, right? If my wife is looking for me and she doesn't need to know anything in New York, in Boston, or home, right? She knows my phone number, she called me, and she can talk to me. That's exactly how location transparency works. But we are to the money, making this part here, which is code quotation. So, anybody familiar with code quotation? All right. So, I have some slides later coming, so we're going to cover code quotation. But unlike C#, F# API is we're able to use code quotation to construct actor, right, using expression. And so we can compile directly at runtime and remotely the code using code quotation. Code quotation is a language feature in F# that really enable you to generate an abstract syntax tree, and we're going to cover later. So, but the main advance about code quotation compared to C# link expression, for instance, is that you can serialize code quotation. We're going to see later you can inspect code quotation. Right? So what about if you use code quotation to serialize our function, which is our actor behavior, and remote deploy the behavior, right? So this is pretty cool. All right, so let's start with the demo. So let's cover remote deployment, right? And we're gonna cover both the basic actor, but also remote deployment. Just to have a feeling, how many of you are interested to see Docker in action well? All right, I'm gonna cover that. I left it for the last with Tabasco, but I'm gonna cover that. Okay, so remote deploy. So the scenario here, as you can see, I have a Mac here. This is not coming out. It's okay. All right. I have a Mac here, and I run my Visual Studio using a Windows VM, okay? So for the first demo, what we're gonna do, we're gonna have a actor model running in Xamarin, which is in Mac, okay? In this case, the reference used here is small, but trust me right now, there is nothing beside the akka libraries. And what is configured here is just this piece of code here. What it does is just spawn a system, no actor implementation here, okay? So let's run this guy here. Make it bigger. Now back to my Windows machine, okay? Now, my Windows machine is, this is just to do helper function, just to remote deploy an address. In this case, we take a string, which is my IP, and use the deploy remote, which is the remote built-in in Akka option. I pass the address, and then I spawn the actor using the spawn in function. What is interesting here is this argument here. By the way, anybody can see the code? You want to make it bigger? Good. Is an expression, interquotation expression. We take an actor and a continuation, right? So this is our actor. This is a simple one. Then we're going to build something a bit fancy. What we're going to do, we're just going to send this code here that print a number with our message. But to make it true, Michael, can you give me a color besides cyan?
I'm sorry? Oh, I don't know, purple.
What? Everybody
I'm
took
kidding.
purple. There is
I'm
no.
kidding.
There is
I'm kidding.
magenta. Much
I'm
magenta.
kidding.
You know what? Everybody, Ray, give me a number.
50.
50. All right. So I just gonna send all the code here in a repo and create my system. Let's make it a bit bigger here. Presentation is off. Presentation on. Ah. All right, well, we need probably the repo YAML for this code sample here, but not much. All right, so I prepare my actor system here, and remotely nothing happened yet, okay? Now, I use my spawn remote function here to remote deploy my actor. Okay, it creates some binding here. Nothing happened here, but now I can send a message for the New York City F# user group. And now I send the message. Now locally here, I print unit because nothing happened in a local machine. But if you go to my Mac, I send there my actor, right, with the magenta, which you remote deploy. Pretty cool, right? Everybody like it so far? Yeah. Okay, that's great, Ricky. You send a magenta code. But let's see something a bit more interesting, right? Well, how about, I have some functionality here, so the configuration, I'm going to cover this part here, which is the same helper function here. Okay. My remote system, actually, this is the Docker machine, we're going to see later. I have to copy here, hold on a second. We're going to go back to the Docker machine. Because I will run the same code also in the Docker too, but that'll be cool. So now I'm gonna wrap not just a simple console, but this case is a very simple basic implementation of the k-means and start line 53, okay? You see the code quotation start here, and I scroll down, I get some random, some k-mean distribution here, actually. And here is my actor function, that is the last part of the function, where it wrapped all the function that I exposed earlier, right? And send back to the sender the result. In this case, the sender is my Windows machine, right? So let's wrap up all this code here, hopefully. I forgot that it's there routing too. Put some assembly here, okay. Not defined round robin. I know I forget something here. Okay, that should be good. Hold on a second. This is pass. Let's pass the dependency. Oh, I know why. My bad. So the sender is going to receive back to a Windows form some UI, and I forgot to put dependencies. So I just use send reference to the F# interactive. Now all the F# reference here that they are including the Windows presentation foundation and so forth are here. So I forgot that. Sorry about that. So now actually if I pass my reference, it's happy. Now if I pass my round robin here, it should be good to go. Let's try to localhost care. Okay. Local system. Okay. Okay, now it's passed. Now I just collapse all the functions to make it easier. I just grab some data here that I might actually need the internet. Oh, okay.
Where's Wi-Fi?
Yeah, sorry about that. Anybody know a joke when I connect here? Rick, know a joke? I'm gonna use my phone here. This is it. Sorry about that. And I mentioned in the beginning that I know I was forgetting something to set up. Okay, now my phone is on. Okay. Windows preference here. So if Spider-Man was looking for a job, you know what it could be? A web designer. Ouch. All right, is getting up Wi-Fi? Okay. Okay, let's see if I can grab these guys here. Okay. Sorry, but I now reload the data from our website there. I pass all my function here, which again include all my actor and everything. Oh. Remote actor is not simple. Oh, I know. I'm just gonna reset all the interactive assembly. I think I have a config the same name that I was using.
Don't forget to send all references.
Oh yeah.
So what is sending? To interrupt. Yeah. Okay.
Okay, so okay, everything is up, running, created by session here. Now, again, here, that's okay. The exception because I call the connection with the previous actor. But now, he already logged processing Euclidean, which means it received message. So as you can see, I didn't have to restart the actor system remotely, right? All right, so now I'm gonna pass my, there is some code here that just sent the data to my actor, which is processed, and receive back using a local actor, using the option, the synchronization dispatcher, because they're gonna print something to the WinForm. All right. Okay, let's run it. Now if we go here, we have some extra login, say receive that 150, clustering, key means, blah, 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 return back, and we're gonna go back. We have our key means result. Just pretty cool, right? But we can do even further down, right? So this is actually part of the example we're gonna cover later. And then the fractal, which is actually, this was the grand finale, I call it the grand finale, for my another implementation. But let's run this guy here and see how awesome it is, but there are some limitations, right? So it's composed of 3 projects actually. The fractal remote here, which is another process, but you can see it just nothing else than an actor system, nothing, no actor implementation. Expose a port, 8090 is fine. My server implementation use some ugly WinForm code, don't worry about this part. Some functionality here, what it does, you're gonna have a WinForm with a picture, gonna cut the picture in slicing tail, then send to the remote actor this tail, which is gonna process some Mandelbrot algorithms and send back and build up to the local one. Yes. All right, so let's run the fractal now. I'm gonna say something here, but you can see this is the actor system didn't know anything about it. Now start to log because something received ready for the implementation. They're ready to receive messages and process the messages. If I click start, now I start to receive the message, the actor, and process the Mandelbrot here. So you see the loop, right? Nothing here, a remote deploy an actor, send the messages, they send back here, which is cool, right? I was expecting to be, yeah, it's cool. Now, this is okay, but we can do a little bit better, right? This is where we can use some feature called round robin here. What about instead of 1, I'm gonna put 6, I don't know. What's happened now is that my remote actor, actually, the actor system, is gonna create 6 actors, okay? And now dispatch and load balance the work using round robin algorithm. I'm expecting what? I'll be faster, right? All right, so the remote actor received some implementation. Now the behavior is there. Code quotation is arrived, deserialized, inspected, and build up some actor. And now, yeah, it's faster, right? Yeah. Now, if I check my performance here, I can see this 100% utilization. And my Mandelbrot is coming up. Pretty cool, right? All right. Okay, so then I cover remoting. We saw how using code quotation, this is this part here of the code, I can send a remote behavior to a system, they receive the behavior, create the actor for you, and so on. Yes?
When you send the 6 to the 6 actor, that happened only on the virtual machine, on the Mac.
Right, yeah.
But can you send that to a cluster of machine, meaning not only on one particular system, but say, here, I have a payroll, process this thing, use everything in the cluster that we have available.
It's coming an example later. There is not really, like when you have a cluster, right? We're gonna see later. You can start a cluster with 2, 3, 4 actors. However, it's not that your scalability stops to 6 actors. You can have some settings that you can tell the system and say, well, whenever the payload increase some sort of value, right, you can spawn more actors. And the beauty about the clustering is that when you spawn more actor, it's not just limited to the current process, right? It can be a different machine, right? We're gonna cover that. Yeah.
But the actor itself is just a service running on the virtual machine.
The actor, well, there is the actor system. The actor belongs to the actor system, right? But about the clustering, the cluster belongs to the actor system. However, you can have different cluster belong to the same actor system, not just one. It can be different one, right? And then there are 2 types of actors that we cover later, but there are the actor which is a node, and a seed, which is the one used actually to spawn more actors. We're going to cover later. If you don't answer your question with the coming slide and the next code sample, we can talk in the end, okay? Yeah.
Are you, is the actor that created 6 actors, is that what constitutes the cluster?
Not in this case. In this case, I create a remote actor that is a router, right? So in this case, it is a router actor that creates 6 routee. Okay. So I send a message in the router to dispatch the work between the 6 routee and load balance the work between them.
Okay.
How does the Mandelbrot type there get sent over?
Yes, thank you, Rick. And this is Tabasco. Yeah, we're gonna talk about that. This is the limitation about this code sample. Because now we have, I didn't pay him, but, so the project here, is a Mandelbrot. It's pretty ugly C#, right? But, yeah, this is a very good point. We have the fractal here, we have this function here, the Mandelbrot, right? Which this actor here is the remote deploy. So how is able to get this library? Well, it can't right now. I mean that the remote system had to know this library. So are you going to overcome this limitation? Stay tuned, it's coming. All right. Any other question?
So far in the demo, you already had the Mandelbrot functionality installed on the other machine.
It is here.
Okay.
And actually it was close enough to them with that. So thank you, Rick. All right. So how are we going to overcome this limitation? All right, let's go back to the slide. So how many of you want to cover code quotation a little bit? It's only 4 slides, so I'm just going to go pass through a little bit just to have an idea for those of you who don't know. But so code quotation, right? So we already see in action with the actor, but what does this? What are code quotation, right? Well, in F#, you create a code quotation just wrapping your code in a this funny operator right there, left arrow at and right arrow at right arrow. And then what it does really surround this code, so you can have a valid semantic, right, and type checking, type correct code wrap in a code quotation that actually is going to notify the compiler and tell it, well, don't compile this code, okay? What it does actually, it returns an expression, integer expression, it doesn't compile. So in this case, sum 5 is not the number 5 in this case, it's the expression that represents 2 plus 3. And of course, the code quotation, you get a compiling error, but it needs to be a valid function, right? Something that actually return a value or something wrong. But, so if you check the type of sum 5, in this case, is this quotation expression that represent this abstract syntax tree of our 2 plus 3, right? So, as I mentioned, just instead to compile, that's what you're going to get back, right? Which is the up addition, value 2, value 3, and you can expect the value using the row API, whatever. But and then you can also compile and run, right?
So what does the none at the beginning do?
The none there?
Yeah.
I think because it doesn't call. I think this is for the lambda because there is no lambda.
Okay.
I think it's because it's not it's like a static method, quote unquote.
Oh, okay.
That you're passing 2 things in. It's not, like, I think that none would be filled in with an object.
Yeah, could be. I have to check that. Because,
Oh, you mean static as opposed to member?
Yeah.
Yeah.
but then, so you can expect this syntax tree, right? And you can use a function, recall this function, and just walk through. Now, here I just covered what we just saw in the previous example, but I think 32, 34 different cases that you can cover. But this is great because code quotation really, I use the case that I see using really when you have some cross-platform compilation, right? Maybe you want some GPU programming and so forth. In our case, actually, we leverage code quotation to serialize it and send it back and recompile it remotely, right? Think about, like, if you're familiar with .NET, like the iQueryable in C# is almost the same here, the return expression. And so this is the part where we serialize the function, right? Because function programming, we like to think the function are valid, okay? So because of that, should we treat the function really as a value? Like, yeah, we compose function apply, function query. But if you really want to treat a function as a value, you should be able to serialize the function and pass it around too, right? So that's what we can achieve with code quotation. We use fsdeclare. If you're not familiar, it's a F# library specific to be able to serialize F# types, like discriminator union, record type, and so forth. So it knows about this type.
What's the library's name? Sorry, I didn't hear.
fsdeclare.
Oh, okay.
And what it does really is serialize the code quotation in a byte array format, right? Almost like that. And so then you can get the byte, send it remotely, reevaluate it, and you get your result back. An example, our actor, right? That's how we use it. So we have our implementation of our actor, which is fine, but the function, the behavior, we can just wrap it. It's just a function, right? We can serialize it, send it back. So that's actually how we are able to remote deploy an actor. Any question about this part? One question? No? All right, so I'll go back time here. Okay. So let's cover a bit of Docker. So, how many of you heard about Docker? Everybody. Right? It's the new shiny star. And how many actually you use Docker? Okay, a few of you. So what is Docker really is, it really make it easy to you to deploy images, right, that contain your code, contain containers that contain code, right? So in a traditional way, right, we have your code source, which you send to the build system, right? And you're gonna get back some artifact. But the challenge comes when you get, your compiled code and you try to remote a different platform, right? So different maybe server, different VMs, Linux, Windows, so forth. Well, the challenge comes, the versioning, different dependency in assembly, maybe one server a different patch than another one. So there is always the thing that it works in your machine, right? So Docker really try to kill this thing and make you be able to create these distributable and shareable containers that work exactly the same regardless the platform you deploy. But there is more. So, well, I'll be covered about this, but really what is great about also Docker is open source and is pretty easy to use. We're going to see in a code sample. But if you think about the traditional approach, right, your infrastructure, this is actually use already hypervisor. I want to forget about one app for one server. But the more modern approach, you have hypervisor with different VMs, right? But even with this approach, there are some limitations, right? Well, you still like to share all the resources. Besides, each VM, it still needs work to be prepared, licensing, operation system, patching, maintenance, and so forth. So it's a better solution than the traditional one, but still there are some issues right with that. So Docker, you really make this way easier because now you remove the hypervisor, and really what it does is share the host operation system kernel among all the images, right? And we're going to see later about the images, how you can build it. But you have to start simply go to the website and download the toolbox, which provides a lot of tools.
And animals.
Yeah, very cute, very friendly. So we have a Docker client, which is the one used, we see now coming in sample, how you manage and handle images or containers, right? So we can start, stop, create containers, and so forth. Docker Compose, we're not going to touch Docker Compose, but what it does is when you need to build some very complex system, Compose the right tool, right? When you have like different containers, they maybe have to communicate, like a Mongo container, they need to talk with another container. You set this kind of complex system. Docker machine is to handle all your virtual machine that handle all the containers. Usually, you touch Docker machine just a little bit, just to know the settings, the environmental variables that you can share. Kinematic, well, this is like the graphical user interfaces of Docker. Now, this is all command line, and we're going to use command line. But otherwise, there is the option of this tool here, which to me is still not there yet. You have, I think, more power with the command line. A VirtualBox, well, when you install Docker in your Windows or Mac, install for you VirtualBox if you already have like an hypervisor built, right? They announced that they will provide proprietary virtual hypervisor for Docker, and of course you are able to switch VirtualBox for what you like. So images, really think about as a cake, right? And each image is built of layer, of containers. And when you pull down an image to your system, you just pull down all the cake, right? So what I mean with this layer? Well, it means that when you pull down a Docker image, each image is composed of different containers, right? And the great part about this approach is that they all share. They're very fast to build images because they all share this layer. Think about if you pull down an image for F# container, an image, well, probably you would also pull down mono container and so forth, right? Well, when you pull down another image, maybe to run SP core, if there are the same container already downloaded and pulled, they'll be reused, right? Think about really like a blueprint, right? Like when you create an image, and we're going to see how you can create an image. Really, you create this blueprint, this read-only template, right? So you can compose and recreate the same containers in every sort of environment. It gives you confidence they're going to work in other machines. Really, the consistent building process. So Docker file is probably too small, but that's how you define a document, right, with a series of instructions to build your image. So you have from, in this case I just download from mono. You can set some environment variable, in this case a directory. And then, the directory we set here is always targeting the directory inside the container, okay? I create directory called var/code, and from now on, actually, all the instructions are going to target this folder. I copy the source code from the current directory, and then I build using the xbuild of mono to build all the project, right? And then I suppose for 9234 and put my entry point to run this example, right? So this is a very simple example, but more complex. Like the run instruction can have different kind of operation. Like you can attach it with a double end operator like Linux and so forth. But again, really you have this Docker file that you just pass to the Docker build process and create the image. And the image is going to be exactly the same whenever you run it. And when you're done, well, you can push the image in this Docker hub, which is think about like the GitHub for source code, right? You can share your image, and you can put it in your repository. You create an account, you have like limited images to push, and one private one, right? They could be, one you can share for your company and so forth, or you can buy it. But otherwise, for free, you get one private and as many you want. So it's fun just to play with. Any question about this part? All right, so I'm gonna demo Docker. Then I probably have, okay, let's demo Docker a little bit. What I will do, actually, I'm gonna keep it simple for timing here. I don't want it much too much time, but close here. All right, I have my command line here. So, well, let's go back 1 second to my code here. In summary here, actually I already have a predefined Docker file that is exactly the same that I showed in the slide, right? But what it does here, it just copy the source code from the example and compile it in my containers when I run it. All right, I think I have to change the port here before I make a bad boo-boo. So the container IP of Docker usually is 9800, but you can change it. And if you have multiple Docker machine, also the IP is different. Okay. So I already set up my my Docker here. So first of all, I can check my containers, which there are no, because usually you're displaying the running container unless you pass the argument around there is already an Akka container. Yeah.
You mentioned before that there's this like, what did you call it? You don't have to care about where things live, right? Transparency for locations or something like that.
Right.
But in this case, you're actually putting the IP address in there. Could you set it up so that you can instantiate your Docker image and it somehow registers back with you. When you run the Docker image, like it registers the
Oh
next
yeah,
thing.
you can pass. Yeah, you can configure that.
And then everything is invariant after that.
Yeah, you can configure that. Yeah, is you have to change the Docker file. I think you have to actually change the compose. There is one caveat actually working on it, Akka, that there's a limitation on Akka that doesn't support NAT. So when especially in a cluster, you cannot use port. You have to have a defined IP, right? You cannot put like 000. But yeah, you can configure the port. You can be one. I check my images here, see if I'm still online. Okay, so if you go to the repository, there are a bunch of those. There's also the F# one. So it's already here. So, but to download, actually to pull an image from the Docker Hub, you just say Docker pull. In this case, F#, which is the name of the image. In this case, it tried to check the latest one. It checked the latest against the one that is current there, because if I put the option latest, it always try to get the latest one available up there. If is no changes and the latest is matched to the current one present in the current machine, it doesn't load anything, right? I have some issue here with the network, but that's okay. Let's run it here. It's just going to say nothing. I have another bunch here. So to run a container, in this case, where you see the build Docker images, I have the F# one. So let's run the F# one. To run a container, you just say Docker run. Okay. In this case, is I pass the option I because it's interactive, and I'm going to just pass the F#, which is the name of the image. What it does, it just create a container pretty quick, and now I am able to run F# interactive here. And to be sure that I'm not in a local host, is all isolated in a container, I can check my, I think it's source directory. I always make this stuff here. Okay, you see, the current directory is the root, which is like Linux box, right? So this is completely isolated from my Mac OS. Yeah, network timeout. That's fine. All right, so let's exit for this guy here. All right, so what I want to run here right now, we have an image that will be built using the Docker file that is part of my solution. All right, so to run and create an image from a Docker file, we just create Docker build. I'm gonna pass the oh, directory is wrong. CD, let's see if Docker file is here. Yeah. Okay, so build Docker build. I'm gonna pass the F function for F option here to specify the type file. If it doesn't specify, you can just take the Docker file.
Spelled like command wrong.
Type in Docker.
No Docker, yes. Okay. So in this case, I'm gonna run the Xamarin project, right? So because the NAT limitation, I have to expose it as a host right now, which is not awesome. You can expose it right to the port here, but I think going to be fixed shortly, this constraint. However, it's not really a big deal. It's just that it creates a map between the host and the Docker, right? But you can set the Docker to run the first available port, so anyways, you're good to go. And of course, the dot here, Docker build. Oh, that's right. Oops. I give you the name or any name, Rick. Let's call user group New York City, and the dot is a current folder, right? oh, the tag. Okay. And now we just go through the Docker file. Now is the run the exec build from Mono, build out the project, and now the source code is up and running there, right? So if you check now the Docker images, now there is the first one here, the one I created, the user group New York City. So now let's run this image, right? So Docker run, and it's interactive because it's a console app in this case. So I have to put the I, otherwise you're gonna go through without wait for the console read line. As I mentioned, I'm gonna put my net here for the host, and now I'm gonna put the name of the container. In this case, it's Rick, user group New York City. All right, so if you see from the layout, pretty much resemble what we saw when you run from Xamarin. The difference here is now is running in a container of Docker. Now for the okay. Still running in the back. Okay. Let's go back to my Visual Studio, right? And just for an example, I don't want to go through too much here. I want to cover well Tabasco for dependencies deployment. But I'm going to run the example about which one you want to run. Let's run the. Let's rerun just the console one, okay? All right, so the interactive here, let's reset. Okay, I'm gonna just send the same code we saw before, right? But the difference here is that we have still the Mac here. I'm gonna push both, and now the Docker, right? Which you can see in map to the port, to the IP of our Docker, and the port that is exposed, right? So let's change the number with 42. Now I remote deployed my actor. Nothing happened here, but now if I send a message, it's on my Docker. Okay, pretty cool. So you can see simple as was running in a Mac using Xamarin, right? You can do exactly the same thing. Any question about this part? All right. I probably want to, well, timing, yeah, 50 minutes total, but we're going to cover Tabasco, which is awesome. So clustering, just nothing really fancy. Clustering is just, a group of working computers that run in a common task. And really built on top of Accra remoting module that we just saw, and provide fault tolerance, scalability, and also load balancing out of the box. Just to answer your question before, the cluster is able to understand the state of the system and spawn more actor, but also more cluster in different machines. So really, how does it work? Well, you have your server, right, that you start to receive a lot of requests, it struggle, so it starts to be might be overwhelmed. So you really can get help from the cluster. It just spawn up the other actor in another machine and start to load balance the work. What's happened now that is all these machines, they communicate each other to be sure that the work is load balanced among them.
So, from your perspective, writing code, it looks like you're just using this one machine, but then it gets overwhelmed in it.
Exactly, that's pretty awesome. That's actually what is very fascinating, right? Mm-hmm. Because you have the same API, you just change the setting, but it's all configurable. I'm going to show you. And it's only possible because gossip, right? It is the special message that's spread around actors. And there is a special actor called seed that is actually the one that starts the gossip, right? And then the gossip just a special message that spawn around between the actor. They talk about the current state of the system. And it worked pretty easily, right? I mean, you have your system here between actors communicating each other. Well, if a lonely actor decides to join, I just send, hey, can I join your cluster? And I send a message to the seed, because the seed is the only one that is capable to make decision if the cluster can join, the actor can join the cluster. So the seed respond back with an acknowledge, and the actor start to belong to the same cluster. But when belong, now the seed spread the gossip also to the other nodes. So now all the nodes know about the new actor they join the cluster. And actually the configuration, it's pretty easy, right? You just pass the new configuration with your seed node collection. You can be more than one. The only gotcha here is that the seed compared to the actor had to be a very specific port, because actor had to know to who to ask to join the cluster, right? So in this case, it's a worker, so it doesn't matter the port exposed. In this case, it's 0, which is the first port avoidable. But it knows the seed to ask. And the seed, which is the master in this case, it had to be very specific. Yes?
So on the node, you don't need to have any other software installed but the actor. The actor will manage all the gossip between the other computers. So you can have a plain Linux batch running just this actor program.
Well, the actor system is going to take care of it for you, right? The actor system is the one that is capable to, they know about the cluster and about the remote deployment and the dependency assembly. That's what you're asking for it? Then,
Yeah, like if I have a plain box, how do I join it to the rest of the cluster? I just run the actor and then we'll manage to communicate.
yes, that's fine, yes. Yeah. All right, so last part, but Tabasco, right? So this is what was kind of working on it. That's where overcome the limitation of the assembly dependency deployment, right? So you can dynamically load module or dependencies between different actor systems. However, as we saw so far, you can remote deploy behavior on actor, right? But we didn't see the hot swapping. Because actually, as it is right now, you can remote deploy with a code quotation with some workaround, but you cannot hot swap an actor. You can put it down, create a new one, right? Well, now we can. We see with something I call dynamic actor. But anyways, so this is the scenario, right? We have our cluster actor with our seed, okay? And our actor that send a message to our seed. So I have an implementation actor. Now in this case, this is all plain cluster of actor with no actor implementation, no knowledge, right? So how this Tabasco works? Well, when an actor when a node join a cluster, right? Actually, there is an underneath event system where all the nodes registered to the cluster receive this event. This is actually pretty much how work the gossip, right? So what it does, well, if you send a message to the seed raise this event, right? But because there is no implementation of the actor, well, when the other actor receives this notification, well, the F# code will pass through all the cluster now, okay? So all the cluster now, all the actors that belong to the cluster now acknowledge, and now they are this implementation of the actor, so able to receive messages and deal accordingly with the implementation of the actor, which is pretty cool. But now, okay, send the message, everybody's happy. But now, what about if, like Rick pointed out, you have an implementation that uses third-party dependency, like the Mandelbrot case, right? Well, in this case, if you run it here, you will deploy your actor, well, you still manage the dependency. So you don't want to go there, manually out the dependency, or deal with this kind of pain, right? You want to have like a system that is able to share for you the dependency. So in this case, when you send the message, well, the seed say, well, I don't know anything about these assemblies. I don't know about the dependency. Can you send me something about it? Of course. So in this case, you just pass in memory. You're going to see how it works. But just pass in binary format the assembly, right? And the seed create a local folder. In this case, is cached in memory, you can store it, persist it, but I think it's a bad idea because if the system go down, poof, everything go away, right? And besides, this process happened one time, right? Again, same process, the event fire up, all the nodes belong to the actor receive the event, and now everybody create their own version in cache and memory of this assembly. And again, this actor belong to the same cluster, but can be in a different machine too, right? Yeah.
So what happens when a new node now joins the cluster after you did this?
Well, you still notify the seed, which fire up the event. So at this point, the seed is gonna send the assembly to that. So now the nodes be able to handle messages, and you don't have to worry about dependency and everything. For the hot swapping, the dynamic actor is this is like the simple implementation, right? But what it does is just an actor that have a state that you can load and reload. So it spawn up the first time with the serialized code quotation implementation on your actor and start to work, and then you can reload a new behavior to the same actor. In this case, of course, we use an untyped actor, right? Because anyways, you cannot change the state. And just use the load message. And of course, the seed above the dynamic actor is able to send the dependency knowledge, including with the implementation of the actor, if there are any dependency required. Is built on top of Vagabond. Anybody know about Vagabond? Vagabond is an open source library that is used to like assembly receiver is able to assembly resolver is able to resolve the assembly and dependency in your program, right? All right, let's demo this. All right, so let's close this guy here. So let's make it bigger. So this is actually, you see Tabasco, but here we call it Kiri, because the name is not inconsistent. So I'm gonna walk through a little bit, if you have time, to the implementation. But just to have a little example here, a simple one. I have the worker one. Let's make it bigger. Okay. So this is actually a cluster, right? But this example actually run a cluster of 4, but I'll have a better example later. So the configuration is the same with the remoting configuration. However, there is this Tabasco configuration, which you just acknowledge where to put the cache of your assembly, and because you want to be polite, you want to tell, well, this is the assembly and reference that already I have here, that I know about it, so don't worry about this part. So when they send you a message to send me what I need to run this actor, send me everything beside what I already have, right? So this is just a plugin built on top of the actor system, and you can see it's just simple. In this case, there is no actor implementation, right? So the example, the first one is very simple. We have a hot swap example. So we have our configuration here with the Tabasco part. So there actually no assembly dependency. The next one is dependency resolution. We have 2 actor implementation. One is increment, which as you can imagine, just increment some state that actually defined here with the record type. Then I have a second behavior, which is decrement, which is just decrement the state. Pass a different color, in this case magenta and yellow, just to have some sort of UI feedback that actually change. I use the PD plugin to the system that wrap up the system and now is acknowledged to use the dynamic actor remotely. So when I send the first message here, sorry, when I create the first actor here, it passes the increment implementation behavior with 6 nodes belonging to the same cluster in this case. Okay. When I press the keyboard or when I go through, send a message, increment the number. Then, in this case, I use the client reload and I pass in a different behavior. So now I hot swap the behavior that I moved up. Okay? Is it clear? Okay. Let's run it. Here I just copy the file between the two. Fine. Let's start the master. Okay, the master is up and running. Now some actor is joining here. You can see here actually create a log 6 times because 1 for each actor that belongs to the cluster. Okay, so if I send now the increment behavior is uploaded, and now my 6 node for the cluster have the run the increment behavior. Right now, if I continue, you reload with the decrement. With the magenta, I just decrement the state and I'm back to 0. Pretty cool, right? Hot swap. Any question about this part? All the slide and code sample are on GitHub. We're going to send you the link at the end. I mean, I give you the link at the end. You can download it. Now, to solve the fractal example. So now I have the fractal example here, which have a Mandelbrot. The worker is just a plain nude actor system. Actor system. There is no reference to the Mandelbrot library, right? You leave it? Yeah. Right. I send you an email, okay?
Okay, yeah.
But it works, okay? So there is no Mandelbrot reference. The master here is resemble the code we saw earlier, just of course with our Tabasco configuration. Scroll down to the part where the tile here, I don't care. What is it? Okay. Now I use my Tabasco plugin here, and I send my Mandelbrot behavior remotely, and I still pass, in this case, my function. So how does it work? Well, as we saw in the slide, they're just going to ask for the assembly because we don't have this reference to run, and there's going to be some sort of handshaking agreement between the two sides, and the assembly is going to be sent remotely to the cache. And then we can run the cluster. In this case, I remote deploy the Mandelbrot behavior, and I spawn 8 nodes in the cluster. Okay. All right. I think this. I don't know why I created this part here. All right. So. Just gonna create stuff here. Okay. The worker, it just spawn n number of workers here with some copy here. So I create 2 workers. I start the master, which, as you can imagine, is our stale picture with Mandelbrot, but in this case we run Tabasco and I remove all the dependency, right? So now I spawn my 2 workers. All right, we have 1 worker here, 2nd worker here, and my master here. Now each worker have my 8 nodes for each, right? Which is pretty cool. Now again, nobody knows about this Mandelbrot assembly, right? Only the master. Well, if I run it, there you go. Come on, it's pretty cool, right? Any question about so far?
I have one quick question. So Tabasco can only send whole assemblies. Like you couldn't have a type. Like if you have a type, you define the type, and then you have a quotation with that type, and then you send it. Can it send that type?
Oh no.
Yeah, I didn't think so.
This is not part Tabasco, solve a different kind of issue. That part is tough. Yeah.
Maybe I missed it, but how did you detect which is the assembly that was required?
How?
Yes.
I'm going to show the code in 1 second. Yeah.
Your project might have other assemblies that you might not use.
Right.
And also, how do you know that the target doesn't have that assembly and needs to be sent?
Well, usually this assembly resolver,
Yeah.
and is able to figure out which assembly you need to run. So,
Oh, wow.
yeah,
So it would check if it is already there, otherwise.
right, that's correct. If they're not there in a cache folder, or it doesn't have a reference in the project, it sends the request that they're missing this code. I mean, it's missing this assembly dependency to run the code, and they're going to receive back the binary format, which you run only in memory, because you can run assembly memory. Right?
And the same applies for dependencies of the dependencies?
Yes, yes,
Okay.
yes.
So, is there any logic or reason to which sort of little white box gets rendered in what order? Like you
Different
seem to have
order?
this right hand moving.
Because in parallel, right? You have is in parallel. So now receive messages for different processing, they process in different times. So it's not deterministic the result.
Well, generally it seems to move from left to right. In general.
Well, so the black tile are faster to be because they're black, right?
Okay.
So the color one it takes longer time. But yeah, so when the worker receives back the message for the client, it doesn't have the right order, right? Because now there are different processes. Yeah.
Which setting or plugin are you using to collapse functions in Visual Studio?
For what? For which color?
Collapsing functions.
Oh, that's the F-sharp tool, power tool. Is that what you're talking about?
I have it. I haven't found that setting.
It's in a setting. Let me show you that.
Okay.
Actually, it's annoying. I want everything. Show me the code. Any other question?
I have a question. What problem is solved by using quotations? Can you without quotations?
Well, the quotation is able to serialize and send the implementation, the function implementation of the actor, right? So use code quotation to wrap it up and send the implementation remotely of the function. Because you define the function here, and you send it remotely. But how are you going to serialize a function, right? Well, you can use code quotation.
I mean, Embrace understands they don't use quotations, right? They just
They hide it, but I think they use it in the back. They must use it.
They have they use the computation expression
Right.
actor that behind the scenes, I think they get.
Because I saw that they just take this kind of function, this object, and just serialize it, you know?
Now, they use code quotation in the back.
So you could use the string representation and like the F-sharp compiler services, right?
Yeah.
No?
Moving
You wouldn't
on.
wanna do that?
I'm kidding. No, yes, you could, but well, it'll be a lot of. I think that for assembly solution, it'll be probably more work. Besides, you're gonna no type checking.
Okay.
You can't query in values.
Yeah.
All right.
Yeah. So, any other question? All right. So, I'm wrapping up here. Ready to save. So, we talked about a little bit about Docker. I didn't go into detail too much, but really it's very simple, right? Few commands, just spawn your container, use Dockerfile to create your images. It just works. It works on my machine, my own machine. Akka.NET plus F-sharp. We talk about Akka.NET, the remoting and clustering module, and how you can overcome using F-sharp feature such as code quotation to overcome the assembly resolution, dependency, and so forth. So they're just happy together with peanut butter and banana sandwich, right? All right. So to summarize, awesome code quotation. We saw how we can load and preload arbitrary actor implementation, which is hot. Yeah, because hot swapping, hot runtime. And again, I just like the idea to all these different tools combine together to find the solution. So really, use the right tool for the job. That's all I got. I'm here for question, and this is my detailed information. And sorry for the slide, but this is also the link for the project. Actually, there is no the Tabasco there. I mean, it's there, but it's not in there. You're still in the same room, but you can find it there. All right? Any question? Yeah.
You seem dangerous. You're basically sending code to servers and allowing them to execute.
Yeah, but the code that you send, okay, there are two answers. Good question. So the question is, what about security, right? Well, first of all, yeah, you have the security of the type checking. I know that's what you aim, but I'm gonna cover the answer. So the code compile and it's not gonna create an exception remotely, right? First of all, this security, like, it's not dynamic language, and we can create some bad juju. Now for the security, yeah, I didn't cover security. You can implement security. There is not out the box. You can implement it though. You can have some constraint there. But like for instance, if you send a delete all file from this folder, well, you can do it in any actor system, right? I mean, the security on the other side is you, right?
If the actor is running in a Docker container and it's like completely isolated from everything
Yeah,
else,
that's true.
that's pretty safe.
Right. Well, so we didn't cover, there is this concept called volumes. You can expose, so Docker can have like a little tiny layer of read and write to the host. So theoretically, you could make damage to the host, but really, yeah, really looking for, right? But anyways, besides, you build a container, so why not shoot your own food, right? So anyway, you're not gonna do that.
Well, you can denial of services and use your cluster. And
Well, yeah, definitely, that's true, right? But denial of service, the cluster is gonna still, pump in and spawn in multiple threads, but it's like other kind of security, right? Probably you want to check different message come from the same IP, all this stuff that is not really care about the actual system. But yeah, actually today was coming here. There was Uber. It was probably the application, right? I don't know. It was stuck. It was not working. The driver was all mad too because the application was stuck. Was hanging, and so I thought, even our company that we are. Every time we deploy some new feature, we do natural language processing to expose sports stat analytics. Every time we create a new feature, like you can query a player by age, then the next day or two we always get an AL attack, even that. So yeah, that's happening everywhere.
another question, just on Akka generally, what's the profile of an application that is well suited to using Akka versus just using regular REST services or
Well, so every kind of collaborative, multi-tenant, like video games can be also another example. I'm pretty sure like you have like this fit quite, if you think about it, the architecture behind the actor fit quite well with and also in combination with Docker microservices, right? Because now you can spawn and create on the fly, microservices or more microservices to scale a specific part of your application, right? Because let's say that you have more requests to handle only for, I don't know, a shopping cart or something, right? You just don't need to scale all your code, all your application, but just that specific part portion, right? So you just spawn more actor in that specific cluster. Or, yeah, I see actor really can be a fit in almost all, sort of high scalable application or reactive application. Yeah.
How we're maintaining the repository? Like how often do they?
Tabasco? Well,
and Akka.
Akka they're actually very well maintained and they have a great documentation. They all come out with new feature. I recently actually came out with the improvement of the persistent module. So Akka.net is robust. implementation of the Docker
But
model.
at this point with Akka, I didn't see you parallel with the Akka on Java, or they just went their own way?
They collaborated lately, in the last year or so. They are a bit out of sync though. Like for instance, Akka.NET is something that Akka doesn't have, and vice versa, right? Like for instance, untype actor, the JVM side doesn't have the untype, old type, right? But they actually just solved the Akka from the JVM solved the problem of running actor in Docker using NAT compatibility. I mean, yes, which versus Akka.NET is still like is not working well. I mean, they are almost in sync, but they're collaborating. The Tabasco right now is one person work, so is yeah, we can download it and contribute and whatever. It's fun, right? It's just I think it's a cool idea.
So can Akka.NET send messages to JVM Akka?
Ooh, George, probably you know the answer, right?
No, I don't know.
You
Yeah,
probably use some neutral queue between them.
Yeah, I think you can use.
We're just saying they're very on par, so they might be compatible.
Yeah, so
Yes.
I know the pain because I do some interop between .NET and JVM code, and I use the IKVM, which is, but it's a different animal. But yeah, I don't know. I think you could, and you could actually.
Enough work, right?
There is a plugin for REST API for the JVM ones, but I don't know if there is something like that for Akka.NET. But
Oh, I take it back. You can use the HTTP protocol.
No.
Use HTTP protocol. Yeah, you're fine. You're good to go.
potentially you wouldn't be able to execute every remote thing.
Yeah, you cannot do this stuff here with Tabasco, right? It's like, but
I just have a hard time trying to see the benefit of loading the assembly dynamically and doing the code quotation. When if I'm not the one managing the system itself, I can create out of the code and the dependency in there, and Akka will manage that for me. They will copy the stuff
but
to the actor, manage it, then when they finish, it will kill it. So
yeah, well, yes. I tell you one user case, that's why actually everything started here. It was when I had to, in rush, because you have a lot of time when you work, to figure out a way how you can really have more power in the back, right? But then think about it like you have like 8 servers in the back. Well, now you have to deploy 8 actor system, be sure they all have the dependency, all have the same assembly. So then, when you're done with all this work, then you can send messages and can handle it for you. And when you're done, you don't need it anymore. Well, you go back, you delete it, probably your project. It takes some time. In this case, it takes care of everything for you, right? So you just send out the request, you send the assembly result in memory, and when you're done, you kill the actor system with the poison pill or whatever it is, and the spoof disappears, right? So.
but when you're using the code
Quotation.
quotation, like I'm new to F#, so and I'm hardcore .NET, so I'm Visual Studio tooling all the time. So do I get the same tooling when I'm using the code quotation? Like I rely on intelligent sense and all the other stuff to simplify me and not typing that much. So when I'm using the code quotation, am I gonna get the same experience, or because they are on the stuff there?
Well, so it depends what you're doing, right? Code quotation really resolve some specific problem, right? If you do classic, I don't know, like beside what we saw here, you can use code quotation to, what's the example, like GPU programming or cross-platform programming. I mean, whenever you don't need compile code, but they need to be inspect, analyze, and process it later on, or do some sort of operation, it makes sense. The tooling, there are few, not great. There is a F# open source called evaluation. I don't remember evaluation. Rick, you know the name?
You mean the fast quotation compiler?
Yeah, something like that.
Yeah.
But the tooling not there. But code quotation is not the solution for everything. Right? It solves a specific problem. This case is great.
But you lose debugging information on debug symbols, right?
Yeah. Well, no, you can use debugging, right? If you put code and code quotation, when you make an error in a code quotation, the compiler tell you that it is squiggle, right?
No, I'm saying like, say, in production, you want, like.
Oh, no, because not compiled. When
Yeah.
you compile it, when you inspect it later, maybe using, when you inspect the EST, you're able to analyze the code quotation, but it's not compiled. So
And also, when you do compile it or interpret it, like the system will give you errors, and you can decide how to deal with that.
No, I'm saying runtime errors, like, I want to have like stack trace and see like if it's a meaningful code that calls some APIs which can fail, right? Like, it's useful in logs, so like it's another question how you gather all these logs and everything, but you lose this kind of line numbers.
But he made a good point. So if I'm deploying after and I after do a specific service, where the log go? Like do the log anything?
Oh yeah, I mean the log is independent, right? I mean,
Well, the log would die when they finish and or in this case they fail and in the rehealing the after will be deleted and created.
oh no, you're in control of that. You can make your decision.
Okay.
Before everything happens, you can inject your logic in the process, login. You can even just shut down the process. You can do
I
whatever.
didn't want to point to login specifically because you can actually, as soon as you capture exception, you can send a message back with
Yes.
this information. But what I care more, like if I get this stack trace, I want to see like line
Well,
numbers.
to me, if you start to debug and you need code tracing, probably you don't need code quotation what you're doing. I don't think that's code quotation is not the fit. It's not fitting what you're doing.
So this is why, for me, like it's still not obvious where it's necessary. Like you cannot avoid quotation.
Here,
Like yeah.
but here I need code quotation to serialize and send remotely a function, because how you can serialize a delegate in C#? Right?
Well, but delegate is just like a class. You just need to know like this, what you know like you know like I don't know like you know you have this instance object which you serialize using this fs pickle, and then I guess in case of F# it's very simple. You have this function object which has this invoke virtual. So as soon as you have this object, you can call it. You just need to serialize this object. I saw this how Embrace works. They just have this advanced like serialization. This is why they cannot port it to core, because they rely on some kind of binary serialization, like deep cellular level kind of. Does it, if I understand it, goes over all this object tree and serialize in binary form and then restore. So then the only problem you solve, you need to transfer assemblies.
Well, so in Embrace, I'm pretty sure use code quotation in the back. That's pretty sure. And for the assembly is over, because they are in control of the environment where they work, right? If they work in Azure, for instance, they have some sort of operation that they share the assembly because they know where they hosted it, right? So they know that they know how they can share the assembly in the specific environment. They know where the environment
So what
is.
I'm saying, like the code is kind of static, right? You have this assembler and it has all the code. The only thing that you need, and you ship assemblies, you have this mechanism. So the only piece you need when you kind of initiate this kind of action that should happen remotely, it has some kind of this state, some initial like the state that you capture, right? That you want to ship remotely, pass some kind of parameters, that something that.
Yeah, but how you pass the state the parameter, but how you going to handle that remotely?
This is what the does for you when they build this function object, right?
Mhm.
It has all this, it captures all the state. So if you serialize the whole state, all the parameters, like
Right.
I think it's just, I'm not sure how Embrace does it, but it is, I am checking the source code and I don't see quotations there, so I think that they might just compile the cloud computation equation, and so
Mhm.
you said maybe send it as a assembly.
Mm.
But
No,
in both cases, I think you are achieving the same thing in two ways. In one, you're using quotations, and in the other one, you are
understand,
sending.
like, I just wanted.
Well, I don't see what is the benefit
Well,
of the assembly
you
against the
lose-
quotation.
No, I understand, but the thing is, like, you lose, like, you have this compiler, the full pipeline, it's like tooling and everything, when you just go to the regular compile step.
But if you need to send a small snippet, yes,
Because you already,
why would you
listen,
send
you're
entire
already
assembly
solving.
if you have the expression
No,
tree?
I understand, you're already solving the problem shipping compiled code, you have this mechanism, because you have all the dependencies, you're already shipping all these assemblies, right? So,
Yeah. You could.
what you need to ship is this runtime state, and it has nothing to do with quotation. As far as I understand, this is why I started with this question.
Let's just talk about it after.
Right.
Yeah,
Take it
maybe we
after.
can get a beer and
Yeah.
talk about this.
Any other questions?
Yes, you can send an actor using string, but it's dangerous. No, okay.
Well, thanks, Ricardo.
All right.
Thanks.